Good evening, and thank you for joining this presentation from Solihull Sixth Form College Mathematics Department. I'm going to be talking about A-Level Maths, A-Level Stats and A-Level Further Maths. My name's Alan, I'm one of the assistant curriculum leaders in this department, and these are the three subjects that we offer at A-Level in this department. So, first of all, these are the three subjects: A-Level Mathematics, A-Level Statistics and A-Level Further Maths. Chances are the majority of the people that have joined thinking they were going to apply for A-Level Mathematics. But I like to talk about all three subjects so that you're aware of what your options are and what the differences are between them. So the first thing to say is that you can't do A-Level Mathematics and A-Level Statistics. It's a case of doing one or the other. There is a little bit of statistics in A-Level Maths, and I'll come back to that in a moment. But in terms of actually picking an A-Level subject, it's either Maths or it's Stats. We also offer A-Level Further Maths. So A-Level Further Maths is a really interesting course which is designed for people that are really passionate about mathematics, particularly people that are going to study mathematics at a degree or going to go on to do a degree in something like engineering, possibly computer science. And so they already know they want something really mathematical as their program. So Further Maths would be taken alongside mathematics. You have twice as many lessons on your timetable, and you come out with those would be 2 of your A-levels. But you can't do Further Maths with Stats because in order to do Further Maths, you have to do Maths, and you do Maths or Stats. Okay, so A-Level Mathematics first. This is our biggest course in terms of the number of students who come study it. In our year 12 at the moment, we've got 15 classes studying A-Level Mathematics. It's normally slightly smaller than that, but this year it's 15. So in terms of what's in A-Level Mathematics, 2/3 of it is what we call pure maths. Now, pure maths is essentially algebra. So if you're going to be studying A-Level Mathematics, it's essential that you're really passionate about algebra. If I was to ask you individually what your favourite bit of mathematics at GCSE was, I would hope that if you're going to be doing A-Level Maths, you'd probably say something like either factorising quadratic expressions where the coefficient of x squared is greater than 1, or maybe using the completing the square method, maybe the quadratic formula. And if any of your teachers have shown you the proof of the quadratic formula by using completing the square, that's really interesting too. If they haven't, and if they won't do so, then by all means ask any of us when you come in September, and we will quite happily do it with you fairly early on in the course. Now, in terms of what pure maths looks like in A-Level, what I would say is that a big part of it is calculus, differentiation, integration. So you should be familiar from GCSE with how to find the grade of a straight line. It should be quite straightforward. You look at the difference in the y values and divide by the difference in the x values, and then you've got your gradient. But if I was to apply that to something like y equals x squared, so a curve, then you can see that the gradient is changing all the way along. At the origin, the gradient is 0. Towards the right-hand side, I've got a positive gradient. That gradient gets steeper the further I move towards the right-hand side. So I can't just look at the difference in I can't just find the gradient between 2 points, because otherwise that's not the gradient of the curve. So what we use is a technique called differentiation, and what we are able to do is to find an expression for the gradient at any point on the curve in terms of the x value. Now, once we've covered differentiation, which at the moment we're just doing year 12s at the moment in college, the next topic would be integration. So integration is finding the area underneath the curve. Now, I've shaded on the graph of y equals x squared, the area between the limits of 0 and 2. And the area looks almost like a triangle. And you could find the area of a triangle, and that's really straightforward. That's GCSE and something you should all be familiar with. But that's going to give me a slight overestimate for the area of this curve, and actually finding the area of this curve is quite a bit more difficult than that. So we use this technique called integration, and the two things together, differentiation and integration, are a really big topic in the pure maths element of A-Level Mathematics. The rest of A-Level Maths is applied, and so we break that down into statistics and mechanics. So 1/6 of the course is stats, and 1/6 of the course is mechanics. For the statistics, we use things like, for example, if I had a dice or a die with 6 faces and I suspected it might be a biased die, so I kept rolling it. Let's say I rolled it 60 times. Now, if it was a fair dice, you'd expect me to get 10 sixes, because that's the probability of a 6 is 1/6. And if I'm doing 60 rolls, I'll do 60 multiplied by 6, that's 10. If I had 11 rolls that resulted in 6s, I imagine most people, even without having met me previously, would probably trust me that I hadn't cheated or I hadn't used a biased dice. I was just slightly lucky. But what about if I had 15? Would 15 be enough for you to say it was a biased dice? What about 20? If I had 60 rolls, that resulted in 6s out of 60 rolls. So every single time it gave me a 6 from my sample of 60, then I don't think you would trust me. I think you'd say, oh, I think you've got a biased dice there, or you've cheated in some way. So what we can do in the stats element of A-level mathematics is we can say, well, okay, I've got 15 6s. What was the probability of me getting 15 or more 6s if it was a fair dice? And if that's a small enough probability, then you would rightly conclude that we have evidence to suggest that it's actually a biased dice. If it wasn't that small a probability, then you might say, well, okay, if I had 20 rolls and so on. So we can find a probability of getting that number of 6s or more. And then once we have that, we can make a conclusion. Do we trust that the dice is potentially fair, or do we have evidence to suggest it's a biased dice? Now, you would do that in A-level statistics as well, but in A-level mathematics, there's not that much statistics. So like I said, it's only 1/6 of the course. There's also mechanics. So mechanics is essentially physics. So if I was to go onto the top of this building, I'm in a building that's probably about 10 meters tall. And if I went to the top floor and I kicked the football out at an angle of 15 degrees above the horizontal at a velocity of 20 meters per second, how far, assuming gravity is 9.8 meters per second, how far would my ball go before it bounced on the ground? And what modeling assumptions have I made? Have I disregarded air resistance, and is that a reasonable assumption? So those together form A-level mathematics. Like I say, 2/3 pure, 1/6 statistics, and 1/6 mechanics. In terms of the differentiation integration, so I'm not going to go through this question. It's about a star exploding. But this is one of the more challenging types of question you can have towards the end of year 13, but it links back to that differentiation. So that idea of when I said about y equals x squared, can I find the gradient at different points? This is where we ultimately end up in year 13 with that idea of differentiation. Okay, so A-level statistics. I said that was one of the other courses I wanted to talk about. And so for A-level statistics, there's a lot about finding probabilities, and there's a lot about looking at data and performing some kind of hypothesis test on the data. So what I have here is a question saying, okay, a manufacturer of rechargeable batteries has developed an extended battery, and the manufacturer is claiming that on average, these batteries last longer than regular batteries. So Jamal's taken a sample of 4 regular batteries and 5 extended batteries and puts them into a torch and records how long each battery lasts for. And then I've got the information on the screen, the data's on the screen. Now, you can see straight away that the longest battery was one of the extended batteries and the shortest battery life was one of the regular batteries. So at a really basic level, you might say, okay, there's evidence that extended batteries last longer. The next step up from that, and something you quite reasonably do at GCSE, is you would work out the sample mean for regular batteries and the sample mean for the extended batteries, and you would see that the sample mean for the extended batteries is longer than that of the regular batteries. It's something you do need to be able to do in GCSE, is compare 2 distributions, and your teacher's probably talking to you about comparing either medians or means and either interquartile ranges or potentially standard deviation, probably interquartile ranges or ranges to look at the measure of spread. So here we could look at the sample means and we can see the extended battery life is going to have a larger sample mean. But that's not necessarily evidence that the extended batteries last longer on average in the whole population. It might just be that these 5 happen to be 5 of the better extended batteries, or I might randomly have picked some not very good regular batteries. In fact, there's a 50% chance that my sample mean was going to be bigger. I would also add in at this stage that it does not matter. There's more extended batteries in my sample than regular batteries. That is not a problem, so don't be fooled by that. They don't have to have the same number in each sample. So this is how I would solve this problem. It's called a Wilcoxon rank subtest. If there are any older brothers or sisters or any parents watching this that have done A-level statistics or something equivalent, then you might have seen this known as the Mann-Whitney U test. It's the same test, but it's now known as Wilcoxon rank sum. So what we do is, I'm not going to go through too many details here, but we essentially rank the numbers that are on the previous slide from smallest to largest, and then we add up the ranks, we perform a statistical calculation, and then we have our test statistic. We then look up a critical value from a table in a big formula booklet. And for this particular test, if our test statistic was less than or equal to a critical value, then we would say we've got evidence that the extended batteries on average last longer. But actually I don't have that because 4 is a bit greater than 3. So I have to accept that I don't have any evidence that extended batteries last longer. Well, that's actually really powerful, because we could quite easily be fooled just by looking at the sample means and have concluded incorrectly that we had evidence that the extended batteries lasted longer, and actually we don't have evidence of that. Now, this sort of question has lots of applications in industry. So here I'm obviously using it about extended batteries, but I could use it for anything to do with mobile phones. If I want to measure texting speed, then if one type of mobile phone allows me to text faster on average than another, that could be a selling point. Or if I was generating some sort of special training shoes, then if those shoes allow people to run faster, then that's going to be something that allows us to sell those. So it's really quite powerful. And obviously, with the COVID pandemic that we've been in for some time now, there's been lots of medical use of statistics. So statistics is really, really powerful, and there's a lot of demand for people that can handle and process statistics accurately. I should add that in stats, we're not too concerned by why this method works. So the calculation behind it, we have to be able to do it, but A-level stats isn't really about why it works. If you want to know why it works, you'd be more interested in the mathematics and then picking statistics modules at university. So for A-level maths, it's essentially we have all these statistical tests. We have to pick the right test for the data that we've got. We have to look at what modelling assumptions we've made, and then we have to say, well, do we have evidence to draw a conclusion? Further maths, which, like I said, can be taken alongside maths, is another A-level. It's something that is geared towards those students who already know that they're looking at doing potentially a maths degree, possibly a physics degree, or something very mathematical, maybe computer science as well. So in further maths, there's again 2/3 pure maths, 1/6 statistics, and 1/6 mechanics. In terms of the pure maths, and I'll focus on the pure maths as that's the majority of the course. So what I've got in front of us is the questions about graph sketching. So sketch the graph of y equals x plus 1 over x squared minus 3x. Now there is some graph sketching or curve sketching in A-level maths, but in A-level maths we wouldn't have a curve as complicated as this one. So we would look at where the curve goes through the axes. We would look at the potentially look at the turning point, but with this graph, what's really interesting, it's called a rational function. The denominator, x squared minus 3x, if you make x equal to 0 or 3, then the denominator is 0, and we can't divide by 0. So what happens to the graph is you get these vertical asymptotes. So you can see the graph goes up to the top of the graph, then it comes back from the bottom, then it goes back off the bottom of the graph and comes back from the top. So these vertical asymptotes only happen with rational functions, and this is something that we look at much more in further maths than A-level maths. So you wouldn't have this function in A-level maths. Okay, so the really important thing to do is for you to choose between A-level maths and A-level statistics. The first thing I would say here is think about what your favourite bit of GCSE maths has been. If your favourite part of GCSE maths has been looking at algebra, so if you're someone who loves, like I say, factorising quadratic expressions or expanding cubics, or proving the quadratic formula using the difference of two squares, A-level maths is the subject that has all of those, extends the idea of algebra, and the algebra is really, really important. If you're not so keen on algebra, you shouldn't be doing A-level maths. But you could do A-level statistics, because A-level statistics it's just as difficult. I'm not saying it's an easier A-level, it's not, but it's a different type of challenge. It's much more about handling data, and in the A-level statistics, it's much more we've got a set of data, and then we see, can we make some conclusions from it. Something else you need to think about is what your other subjects are going to be. So if you are looking at studying, if you want to study physics, that makes things really simple because you have to do A-level maths. And if you are wanting to go and study computing at university, then a lot of universities would encourage you to have A-level maths as well. But if your other subjects are going to be things like geography or biology or psychology, all of those subjects do have numerical calculations and even some statistics in them. And in geography, for example, Spearman's rank correlation coefficient is something which we actually do it in A-level stats, and that's not something that's in A-level mathematics. So to have a nice overlap between your subjects, it makes a lot of sense to go for A-level statistics. So then in the geography lesson, you might be talking about Spearman's rank correlation coefficient, and then in the A-level stats lesson, we then perform the calculation and make a conclusion. and you get that nice sort of overlap between the subjects. There is, as I mentioned, a small amount of statistics in A-level maths, but it's only 1/6 of the course, whereas in A-level stats, it's the entire course. So why choose to come and study at Solihull Sixth Form College? The first point, actually, which I haven't mentioned here, is the fact that we offer all 3 of those subjects. So some of you may also be thinking about staying in a sixth form potentially at your school, if your school has one, and that's fine if that's the best thing for you. But don't do that and then end up doing A-level maths when you're better off doing statistics. So if your other subjects are business studies and economics, and you're someone who thinks, actually, you know, the stats sounds more appropriate to me, I'm not that keen on algebra, please don't let someone tell you that A-level maths and A-level stats are the same thing, because they're really not. They're very, very different courses. And so the next thing I'd say is that we're a very we are a well qualified and experienced set of teachers. There's 7 teachers in the department currently, 6 of us full-time, 1 of us part-time. We're all mathematicians, we all have maths degrees, and between us, most of us have been teaching, we've all been teaching a long time, some of us a very long time. I'm in my 17th year of teaching, and I think I'm about the median of our department. We use technology to enhance learning. Obviously, everybody's gotten used to using technology in different ways due to the pandemic and the period of remote learning that we had. But we already used online learning for certain, not for lessons, but we supplement your learning. We set a large amount of homework, and so for A-level maths and for further maths, we have an electronic textbook, which we give all students access to. So we have one textbook which we use for classwork mainly, and then we have another set of textbooks that we use for your homework. And so we give you free access to those textbooks. We will do the same thing in stats when there's eventually a textbook brought out for the new specification, but currently we have lots of our own resources that we've developed while we wait for actually a new textbook to be written. We also, in terms of technology, we show you how to do things on the calculators. So if you're currently using a GCSE calculator, you may well need to get a new calculator. Well, you will if you're still on a GCSE model. So we will show you we'll tell you which calculators to get, and we will show you how to use that calculator. It's what the students go on to study. So we have a large number of students at this college, and students go on to do things like engineering, biomedicine, finance, accounts, computer programming, economics, dentistry. Of those subjects, if you're looking to go for engineering or computer programming, then the mathematics is going to be better suited to you. But if you are more interested in, well, any of the others, I'd actually say that statistics is at least as good a choice. We have had people go on to study dentistry from statistics, and you can do medicine from statistics. A lot of people who want to study medicine make this assumption they have to do chemistry, biology, and maths. Well, that's a really common combination to go for, sure. But you could equally, for most universities, you could do chemistry, biology, and statistics, and that would be a very strong application. And statistics would actually link in better with biology than the maths would. So please don't go for mathematics on the basis that you think that you need it for medicine. Actually, in most universities, you don't. So to sort of summarise the different courses, we're choosing between A-level mathematics or A-level statistics. Maths is the biggest course. I'm not sure if I said earlier, but in our current year 12, we have 15 classes of A-level mathematics. Not always quite as many as that. But that's what there is in the current year 12. A-level statistics, we have 2 classes, but I think we'd like to see that go up because there are some people that do maths that take it without necessarily realising that they could be doing statistics instead, and it might be best suited to some of them. In terms of the choice between, that's the biggest thing that you need to choose off the back of this presentation. So in A-level mathematics, there's lots and lots of algebra. There's a little bit of statistics, a little bit of mechanics. Whereas in statistics, it's an entire A-level focusing on stats. So there's lots of probability distributions. There's lots of statistics. There's lots of looking at data and making conclusions. In terms of further maths, and I might also mention in terms of further maths, complex numbers, which I think I sort of didn't mention earlier, but in terms of complex numbers is another area of further maths. When I mentioned about the graph that we looked at, that's a topic that's in maths, but that type of graph would only be in further maths, so it's an extension of a maths topic. But there are also other topics in further maths that are only in further maths. For example, complex numbers. So if I asked you the square root of -25, you'd hopefully tell me there isn't one. But we know the square root of 25 is 5, and we say, well, let's pretend the square root of -1 is I. Let's imagine that it's I. Literally make up a number called I 5 for imaginary, as the square root of -1. Then the square root of -25 would be square root of 25, which is 5, multiplied by I, so 5i. So now suddenly we can do square roots of negative numbers. If I then had 5i and I added 36 to it, so 36 plus 5i, that is not 41i, because that would have meant that 36 and 36i were the same, and they're not. So 36 plus 5i is a new type of number known as a complex number. And this entire area of mathematics opens up with complex numbers. Engineers actually find it really useful. They call it J instead of I, but we'll call it I for A-level maths. And this entire field is only in further maths. So in terms of entry requirements, for A-level maths, we say you need to have a minimum of grade 6 in GCSE maths and 2 6s from sciences. It could be a 6/6 combined science, or it could be 2 6s in separate physics and chemistry, or physics and biology, or biology and chemistry. In order to do statistics, we have a slightly lower entry requirement. We say a grade 5 in GCSE maths. That is not because it's an easier A-level. It is not an easier A-level. However, it doesn't have the same sort of algebraic demands as A-level mathematics, and that's why we have the lower entry requirements. But don't be fooled and think it's an easier A-level. It isn't. For further maths, we say you need a minimum of a grade 7 in GCSE maths. The vast majority of people who do it have an 8 or a 9. In terms of your other subjects alongside it, it could be taken as part of a 3-level program. So maths, further maths and physics for the right candidate. That would be, for example, if you're someone who's looking at grade 9s in those subjects and you know you want to do a maths degree, that would be the sort of set of GCSEs we might be talking about for someone doing further maths as part of a 3-level program. But most people do it as part of a 4-level program. There are separate entry requirements to do 4 A-levels. These can be found on our website, but essentially it's that you need 5 grade 7s and above, including a good GCSE, a very strong GCSE in maths and in English. We also offer core maths. So core maths is not an A-level course, so it's not really what tonight is about. But if after you've just seen a few examples, what's in maths and what's in stats, you've thought, you know, actually, I don't want to do either of those, but you want to do some mathematics, then there is a core maths course called an enrichment. So it's not something that you sign up to straight away. It's something that if you wanted to do it, what you need to do is when you come into enrolment at the end of August or start of September, at that point you need to say, oh, I'd like to do core maths as well, and we add it on your programme. With core maths, the entire course is taught in year 12 and the exam is in year 12 as well. It's worth the equivalent of an AS, which is about 40% of an A-level. You can't do core maths if you're doing A-level maths or A-level stats. But if after a lot of tonight you decide, right, I want to go and do, I don't know, let's say business studies, economics and psychology, all subjects that have some stats in them, but you don't want to do the entire stats A-level, you don't want to do maths A-level, then you could sign up for the core maths qualification. Okay, so in terms of how to apply, the steps are on the screen at the moment. So essentially you go to the website, which is on the screen, and this will take you to the stages so that you can put through the application. Now, if there are any questions, and I may not have mentioned at the beginning that we do have a Q&A session, so if there are any questions that you've got, depending on what device you're using at the moment, you may have a little button that you can click so you get something at the side, or you may have to swipe across, but there is a facility for us to ask any questions that you've got. So I've got some colleagues that may be able to type answers in faster than I can answer them verbally, but I'll also have a look now to see if I can see anything that I can answer. So any questions at all, do just pop them in the chat. Okay, yes, so I've just seen a question about combined science, so that's fine. If you're doing the 3 separate sciences, then you need 2 grade 6s. So it could be, for example, a grade 6 in chemistry and a grade 6 in biology, those alongside the grade 6 in maths, that would be absolutely fine. So it's 2 6s from sciences. It could be 6 combined science, or it could be 2 separate 6s. Would A-level further maths be separate A-level? Yes, so something else I might mention about further maths is that in year 12, we're currently the way that we teach it is that you have a class for your further maths, and then you're in a regular class in year 12 for maths. And then what we do at the end of year 12, so when we move into year 13, is we put all of our further maths students into one class for maths. That way you get to really know those students really well, but perhaps more importantly for us is that we're then able to teach the maths course in a different order and teach the topics that you need to have already covered that are prerequisite for some of the further maths topics. We teach those earlier in year 13 so that then students are able to be taught the further maths specific topics all in good time. So it would be a separate lesson. You may have twice as many lessons on your timetable, and you obviously get the 2 A levels. And in year 12, it will be normally two different teachers, and it's a regular class for maths. But when you move into the year 13, like I say, you'll move into the same class for your maths class as all of the other further maths students. Do we think that maths should be done just because you enjoy it? Will it be any use for a psychology degree? Okay, so 2 things there. So first of all, it depends what part of maths you enjoy. So if your favourite bit of mathematics is algebra, which is my favourite part of when I did GCSE, then that's definitely something you should factor into your decisions when deciding what courses to take. What you don't want to do is do A-levels that you're not enjoying. So if you're not enjoying them, I mean, A-levels are difficult. So if you're then doing A-levels that you're not enjoying, they're going to be even more difficult. So doing it because you enjoy it, well, we all do. Everyone in my department does. We teach A-level math because we enjoy it. So it's definitely a good reason to do it. We might then try to, suggest to you're saying about a psychology degree, for example. We might then steer over the 2 years towards doing a maths degree. But if you did go for a psychology degree, now, I'm not going to pretend that I'm an great expert in what's in a psychology degree, but I imagine, given that they do some statistical tests already, or talk about statistics already, I imagine there's a fair bit of statistics in a degree in psychology. So I would say that A-level math, doing maths because you enjoy it is a good reason to do it, particularly if you love the algebra. But the stats side of things is probably what would be even more useful. So depending on what your favourite bit of maths was, you could either do maths or stats. I can see one of my colleagues has written an answer there as well. Yeah. Okay, so we've got a few more minutes if anybody's got any other questions they'd like to ask. So just while I wait for questions to come in, essentially the most important thing that you get out of tonight is that there's not just A-level maths, there's A-level maths and there's A-level stats. They're both really good A-levels to do. Think about, when choosing which one to go for, think about your other subjects. Think about what it is you want to do after you've finished your A-levels. Think about what your favourite part of GCSE maths is. Think about all of those things to help make a decision. And then there is also the further maths for those students who want to do 2 A-levels mathematics. If I pick a subject for A-levels and when I learn about it I want to change it, how long would the deadline be for me to... Okay, that is a brilliant question, so thank you for asking that. Amin, that's a really good question. So there's not a straightforward answer to it though. So the first thing is that when you sign up to those A-levels, we want you to be putting down the A-levels that you're going to do. We will be using the numbers for that to determine whether we need to employ any extra staff, for example. And we will only be reserving you places on the courses that were on your application form. So if you put down that you want to do A-level stats, that's what we're reserving you a place for. If you then decide you wanted to go and do maths and further maths, and we've only allocated for 1 further maths class, and that class is already full, then we wouldn't be able to transfer you over to further maths. Having said that, it's only if something is full that we couldn't swap you over at enrolment. So after tonight, hopefully you'll put your application in, you'll pick the subjects that you think you want to go for. We will then invite you in for an interview, and subject to interview, we'll then make you an offer potentially, and that offer will be on those subjects that you've applied for at that point in time. We then invite you in on the 30th of June or the 1st of July for the Welcome to College Day. So the Welcome to College Day, you have like a taster session in each subject. And if a result of that you want to change your mind, then it's very unlikely that another subject will be full already. It could be, so I can't promise it, but it's very unlikely that another subject would already be full. So provided the other subject that you want to change to isn't full, then you could swap over at that point in time. If you don't swap over at that point in time, then in the summer you'll get your GCSE result at some point in August, and then we invite you in again on, I think it's the 31st of August and 1st of September, on one of those 2 days, to come and formally enrol. And at that stage, it's still fairly common for some students to change subjects, particularly if, for example, if someone's applied for maths and they haven't got the 2 6s in sciences, then they might move into stats instead. But at enrolment, some subjects do get full. So what happens is by the end of the second day, there'll be certain subjects that we're told are full and we can't then swap into them. If you've actually been through the application process and you've then picked your A-levels and you've been to the Welcome to College Day, and then we've set you some summer homework, and then you've been to enrolment and you're still on a certain course and then you change your mind, then it then becomes a case of, well, you need to have a conversation with the pastoral team. So you have an academic coach and a senior manager assigned to you, and you'd have a conversation with them and they would see whether they thought it was the right thing for you and whether we had space in the course you want to change into. Sometimes a small number of people do change about 2 weeks into year 12, but we really don't want to be swapping at that point. We want to have things sorted before that. So it's best to get the right subjects chosen, as soon as possible. Okay, were there any other questions at all? Okay, well, thank you very much for joining us this evening. If any other questions do come up, do by all means just contact us at the college and say you've got a question for the maths department, or if it's a more general question, then ask it to the people at reception. But failing that, then thanks very much for joining us, and I hope to see many of you at the Welcome to College Day in the summer. Thanks very much for your time.